There we go. Okay, so YouTube event, 10,000 people are going to watch. Of course, it's free, obviously, but let's say I'm changing my revenue model. Let's say I'm going to start to charge. I know that if I increase my price by $1, 500 fewer people will watch. Okay, so basically, my price, I'm going to say, is equal to X. And I know my demand function, so the demand is a function of the price. So every time that price goes up, demand will drop, or rather, demand at that price will drop, okay? Because there's a bunch of economists who are turning over in their grave right now. So I start out with 10,000 people demanding to watch my video. Demanding sounds rather strong, but they demand to watch my video. And then for every $1 I charge, 500 fewer will watch that video. So there we go. There's my demand function. I want to find out my revenue function. Well, that's just how many people watch multiplied by the price. And so it's 10,000 minus 500x. And we're going to multiply that by x. We can expand this. So let's just do it now. Get it over with. 10,000 x minus 500 x squared. There we go. It's an upside down quadratic. I know it's going to have a turning point at the maximum. Already I'm optimizing this in my brain. Okay. The profit function is how much revenue you make at that number of units minus the cost at that number of units. However, because this is an internet event, I'm really just going to take everybody's data and sell it somewhere. No, I'm not. Just in case you're wondering, I don't take your data and sell it. But I mean, that's kind of a joke because that's what Facebook does. Anyway, the cost of this event to me is really, it's basically nothing. Okay, so we're not going to worry about the cost. We're just going to go through this exercise with the revenue. Okay. If I want to find the optimum price for me to charge, here's what I'm going to do. This is calculus, right? I'm going to take the derivative. I'm going to find out where the turning point is by finding out where the slope is 0. In other words, I'm going to take the derivative, set it equal to 0. That tells me what price I should charge. Okay, so see here, revenue at X is 10,000 x minus 500 x squared. That means that our primed at X is 10,000 minus 1,000 x. Wow, this is going to be handy. So for a critical point, and this is continuous everywhere, there's no weirdness to it, I'm going to set the derivative equal to 0. So 0 is equal to 10,000 minus 1,000 x. And if I do the math here, 10,000 divided by negative 1,000 is my x. And so basically, wow, x is equal to 10. And this is dollars. So I should charge $10 for my YouTube event in order to maximize profit. Now, we're going to get into a little bit of technical. Make sure your solution is thorough. How do I know that this isn't my minimum profit? Well, it's a parabola, and of course, it's upside down. This one's simple. But in order to make sure that this is a maximum rather than a minimum, because they both look the same when I solve for the first derivative being equal to 0, I look at the second derivative, and second derivative is negative. That means it's a frowny face parabola, and this is the maximum. Okay, so our double primed at X is the derivative of 10,000 is nothing, and the derivative of negative 10,000x is negative 10,000. Therefore, concave down, right? So Here's my function. I know it's concave down, and therefore charging charging $10 is going to be a maximum. I know that for sure. That's going to be my maximum profit. Okay, so problems get more complicated. For example, they might have a cost associated with them. Remember that cost. You have to multiply the price by the number of people that participate sometimes. Okay, anyways, that's optimization in economics. Pretty simple. We'll keep it simple. That's it.